Yep, how are you doing, guys? Welcome to Mathematics Paper 2 exam sprint. So there will be four sprints. The first I'll touch on numbers, the second I'll touch on algebra, then finally mensuration and geometry. All right, so quickly let's go through algebra. Usually for numbers, you will really just be asked typical questions related to maybe time, fractions, recurring decimals, exponential decay, simple interest, conversions, ordering, and all of those. So I just took a few insights from past papers just to go through so you can also build your confidence. All right. So let's take a look at the first question. So the first question here, we are told the following. A concert starts at 1950 and finishes 2 hours 42 minutes later. Work out the time the concert finishes. Now, it's important whenever you're dealing with time that you just really organize your hour in minutes. So we are told it starts at 1950. It's 1900 hours, 15 minutes. And it finishes 2 hours, 42 minutes later, which means we don't need to subtract this, but we are going to add this. So that will be 2 hours added to 2 hours, 40 minutes added to the 1950. Then you just add your minutes together. So that's going to give me 2. This is going to give me 9. Now we must know and remember that when you're dealing with time in particular, you can't have minutes greater than 60. So if I have 92 in this case, this 92 basically means I can decode this down and subtract 60, which will then eventually give me 32. Eventually, that will then give me 32. So which means by my minutes, I'm just really going to have 32. And then I can take the 60, transfer it to the hours. Then I'm going to have here 20 now. 1 plus 19 is 20, plus 2 is going to be that. So that will therefore be 22 hours, 32 minutes. So it's very important for you guys, please, to just know how to deal with your time. And they sometimes ask you random questions like, what's the reciprocal of this? And the word reciprocal basically means to inverse. Sometimes they might give you something like this, and then they will say, no, find a reciprocal of 2 to the power of 3. This is literally just going to be 1 over 2 to the power of 3, which is the same thing as 1 over 8. So sometimes they can even ask you this. But in this case, they asked us in this following one, find the reciprocal of 1 and a quarter. So obviously it's a mixed fraction. So you first have to convert that. So that will be 1 times 4 plus 1, which will give us 5. So the numerator then becomes 5 over 4. The reciprocal of this will basically mean you interchanging it. So that will just basically be 4 over 5. So guys, these are typical marks you can score really when it comes to your numbers. Just knowing this common stuff is very important. And obviously doing that without the use of a calculator. Then typical questions as well that you can get for numbers is something that relates to ordering, where you might just be given to convert. Now, in this case, this was actually drawn from a 2024 question paper. So this was done with the calculator. But just for you to know common certain things, like anything to the power of 0 is always going to be 1. And 1 to the power of anything is always going to give you 1. And then usually what they do is they give you numbers that are represented in different orders, some fractions, some percentages, some decimals. So your knowledge of converting fractions to decimals or vice versa, or converting percentages to decimals is very important, because this is what's going to allow you to actually answer these questions. So generally this one, you either first have to multiply this by 100 and that by 100 to see how it would look like, or if this can be converted to a decimal, then also fine. Then if we do that, we will realize for the first part that this is actually less than that. Similarly here as well, I've got 99 over 900. which can simplify to, this will just be 11, I think. And here you can literally just get, because 9 can go in there, 9 can also go in there. 9 goes in here 100 times, 9 goes in there that time. And if it's 11 over 100, this literally, if you convert it into a percentage, you will see that this and that are equal. And like I said previously in the first one, 1 to the power of 3 is 1, and anything to the power of 0 is just 1. So eventually, even this is going to be equal. So just typical things like that. And these are marks you would not want to lose in an exam. And I'm just saying this out, guys, out loud, guys, so that you guys can just please bear that in mind. Don't lose marks that are like that. It's too easy. All right. Then the second one, typical ratio questions. Here, just now be careful when you're dealing with ratios. Also, there are times in which they can ask you about reverse ratios, if you guys can still recall, but reverse ratios are really typically also for paper 4, where when you are reversing a ratio, if it's an increase ratio or a decrease ratio, then you must know for you to increase a ratio, you need to have big over small, and the other one must be small over big. I hope I did not twist the two. So this is literally like saying, what is the difference? I mean, if I have a half here, that will be 1 over 2. But if I reverse that, it would be 2 over 1. So if my ratio was 1 to 2, if they said the ratio, something is increased by a ratio of 1 to 2, then if we say increase, then you just actually say, okay, now then it's going to be 2 over 1. But if they say decrease, then it's going to be 1 over 2. So that I can just multiply it like that. So I'm just saying this now, even though this question is not related to that, for you to just recall what we also refer to as reverse ratios. All right. Very, very important. Now, every time you're dealing with shared ratios, what do you do, guys? And something that we've done a couple of times, this is you always need to add the ratios. Now, in the exams, they'll obviously give you numbers that you can deal with, not just 5.6s and all of that. So here you are told Sophia has a piece of fabric of length. So we know what the length of the fabric is 5.6 meters. And it's divided in a ratio of 3:4. And like I said, guys, a ratio is just a fraction, right? So she cuts the fabric into 2 parts with the length in this ratio. So there's a ratio of 3 and a ratio of 4. And they said calculate the length of the longer part. The longer part will obviously be the one of the longer ratio. Now, before you start off with any ratio, I know that some of you have got other techniques to solve ratios, but I always like to stick with standard things. The first thing you always do is add up your ratios. Then when you are finding whatever part you now take, you will take, in this case, now we are dealing with the longer side, which is 4. We will then take that 4 over the total ratio. We multiply it by the quantity. Now, this was obviously done with the calculator, but next you get values that you can just multiply like this in an exam, which you mentally have the ability to do. So which means really that the longer one is just literally 3.2. And if that's the case, then that means the shorter one will be when you actually subtract the 3.2 from that. So the shorter one, which is actually 3, is like just literally 2.4. But the correct answer here, guys, is 3.2. I just did this to show you how we can also get the shorter one. So ratios as well, be careful. You might get one of those. And then generally as well, you might get something on simple interest, not necessarily on compound interest, but I'll just shed light as well. Remember, guys, compound interest is A equals to P1 R over 100 to the power of n, whereas simple interest is actually equals to P times what is that, guys? P times R times T over 100. That's simple interest. So this is compound when they say compound. The P in this case represents just how much principal you are investing or borrowing. And the R in this one is the rate. The R in this one is also the rate. And the N is the time. And the T here in this case for simple interest is the time. What is important to remember here is that for simple interest, this is only when you are calculating the interest. Sometimes they will say, how much do you then have to pay back in total? Or how much money will you get back with the interest? If you are going to get the amount of money with the interest, then we say A equals to P plus I, this or plus SI. This simply means I'm adding the simple interest and the principal amount to get the total. Sometimes they can ask you to do that. So bear in mind, in this case, they just told you to do the basics because they just said Edith invests 3,000, which means that's my P in a savings account. And it's an investment. Sometimes they can tell you invest, sometimes they can tell you borrow. The account pays simple interest at the rate of 2.6. Like I said, now in your papers now, you will not get values that are like this. You get values that you can multiply. Calculate the total interest end. You see, like in this case, total interest, which means we only want to calculate total interest end. But sometimes they can ask you calculate the amount of money the person is going to get back after 3 years when you are referring back to simple interest. Then that means you need to add your simple interest to the principal amount to get the overall amount. So in this case, we are told simple interest. So we say SI equals to P times R times T over 100. P, like we said, is the principal amount, which is 3,000. R being the rate, which is 2.6 times T, which is actually 3 divided by 100. Which if you then plug and play, I could have just done this if I was using mental math. 30 times 2.6 times 3 divided by 1 would be the answer. Then that would be 234. So that's the interest. But like I said now, if they asked how much money did the person get back after 3 years in total, then I'll take this interest, add it to the amount of money I invested in the beginning, then I'll get the amount of money. So generally, guys, that's important. Just know how to go about that. All right. And then one of those questions that you will likely always get in paper 2 is really dealing with fractions and dealing with fractions across the board, which means you can deal with fractions where you need to divide, fractions where you need to multiply, fractions where you need to add, fractions where you need to subtract. So all 4 operations can be, and it's usually about 3 marks, sometimes 4. So it's marks that you can get. We all know whenever we are starting off with a mixed fraction, we always need to convert the mixed fraction into an improper fraction. So that would be 3 times 5 times 3, which is 15, plus 1 is 16. So that would be 16 over 3 minus, and this is going to be 3 times 7. 3 times 7 is 21. Is it 21? 3 times 7 is 21. 21 plus 4 is 21 plus 4 is 25. So that we could get 25 over 7. So we've got 25 over 7. So what do we now need to do to then simplify this? So generally what we need to do to simplify this, guys, is to find what we call the lowest common multiple. So we need to find what we call the lowest common multiple by making the denominator literally the same. So by so doing, what we can do here in this case then, guys, is to literally just multiply this by 7, multiply that by 3, multiply this by 3 as well, and then multiply that by 7. Then if we do that, you'll see that 16 times 7 is literally just 112. Because we already made the denominator the same here, 3 times 7 or 7 times 3 is just 21. And then there's a subtraction sign there, and then 25 times 3 is literally just 75. Now that we have that, and you guys might have better ways to do this as well, because there are so many ways. Some people like cross-multiplying. I also love cross-multiplying. And then I simplify, but others also like the canceling part. If you can cancel the fractions, you can always get to the answer. So then I have 2 minus 75. Operate that mentally, that would be 37 over 21. Now, this is not a simplified fraction because it's improper. We need to have a proper fraction, which means we need to convert this into, we really need to convert this into a mixed fraction for it to be simplified. We can't just leave it like that. So 21 does go into 37, yes, only once. The remainder will be 16 over 21. So just like that, you have simplified it. If you can simplify it further, then you can do so. All right, some of the common questions as well that you can get in paper 2 is really what we call exponential growth or exponential decay. Exponential growth or exponential decay. So in this case, we are told, how do you even know whether the question is actually exponential growth or exponential decay? It does not always refer to money, it refers to other quantities. And whenever you're dealing with exponential growth or decay, you just use the formula for compound interest, which is A equals to P1 plus, in this case, we're going to say plus or minus. Do you know why I'm saying plus or minus, guys? It's plus or minus because with exponential decay, they can either tell you it's a decrease or an increase. If it's an increase, you just say plus. If it's a decrease, then you say minus. These questions are also very, they actually often at times also occur on paper 4. So they say at the start of an experiment, there were 40,000 bacteria. So that means this 40,000 bacteria is your initial, which is your P. The number of bacteria increased. So we are told already. So now here we need to choose the positive sign. So we can just write P equals A equals to P 1 plus R over 100 N. In this case, my P is 40,000. So I write 40,000. 1 plus the rate, which is actually 15 over 100. Then here to the power of what, guys? To the power of 3, because we are told that the time is 3 hours. Then if you're doing this without a calculator, that will be 100 into 15 is just 0.15. And then 0.15 plus 1.5 will be 1.153, 40,000. Now, usually for this, guys, you guys will end up like with a value that you can raise to the power of 3. Yeah, one that you can even do, because you can even just do 1.15 multiplied by 1.5, 1 multiplied by another 1.5 mentally to get your answer. Then you multiply that by 40,000. But this was actually from a non-calculator. So the values you're going to get here are values that you will be familiar with. So that you just raise to the power, usually cubic numbers. So 40,000 times that then will give us the following. It will give us the following, just so we proceed. It will give us 60,835. And just round it off. Even if you get a decimal, just round it off. But obviously here you'll get a whole number because you are dealing with a non-calculated paper. Another question that also appears a lot is what we refer to as recurring decimals. Now, recurring decimals basically means you've got a repeating figure or repeating figures or repeating pattern, whichever way you look at it. Now, what's most important when you're dealing with some of these things here is you first take the recurring decimal like that. Usually I like to equate it to F because they want us to convert this into a fraction. So I will just say, okay, F equals to 4, 2, and they put the dot telling you there that the one that's recurring is a 2. Then I'm just make it maybe recur about 2 to 3 times. It doesn't matter. The whole idea of this is we need to move the recurring number over. We need to move the recurring number over. So what we then do is we come up with multipliers. Usually your first multiplier is 10, 100, 1,000, depending on how it will move and how it will divide. Now I'll just show you. So if we were to multiply this by 10, we are literally saying that we expect these numbers to move 1 decimal to the right. If I do that, I'm going to end up with 4.222. And then on the other side, I'm going to end up with 10 to the power, 10f. Now, I have my equation 1 initially, and I've got my equation 2. Here's the problem now. For me to actually solve this, I need to, there are basically 3 steps. The first part is apply the multiplier. After the multiplier, you need to do what we call subtract. After subtraction, now you just need to simplify the fraction. But here's the thing. This is my equation 1, and I need to actually subtract my equation 1 from my equation 2, but I have a problem. The problem I have is the decimals here and the decimals here don't align. They don't have the same number. Now, the fact that they don't have the same number makes it difficult for you to actually then solve. So there are multiple ways now in which you can do it in order for you to solve it. So in this case, guys, the best way to deal with this is to find a way in which the two can actually be the same. So you see in the first one, for instance, I used 10, which makes it very difficult for me to get the same alignment here. So which means the other way in which I could have actually done this was to use 100 instead. You can still go ahead with that, but it will be very difficult to apply. I know that some people are good and they can possibly do the following as well. Although without a calculator, it becomes difficult. So others could possibly do the following. They could just say, okay, no, if I have to subtract the 2, then I'll just say, okay, 10f, which is on the other side, equals to 4.222. And then I have f on this side. Then on the other side, I put 0.422 so that they align. Now, the problem is for me to subtract this here, it's going to be a mess because now I need to borrow again and then, so which just makes it more difficult for you with a calculator. Without a calculator, it's probably far way better. So let me not even get you to this stage. Let's just get straight into how best you can just do this to just make sure that you simplify some of these things the right way. So look, if we were to use 100 in the beginning, then we could have had, okay, 100f, like we took the other one here. And then now we are multiplying by 100, so we expect 2 of the numbers to move to the right. And it doesn't matter how many 2s I put here. I can even put 2 of them. It's fine. Then my first equation will still remain the same, which is still f equals to 0.4222. But since my first equation is still like this, I can actually also multiply my first equation by 10. And if I do that, I will have 10f now. And then this will also move like how many places? 1 place, the 4 will move, and then I'm going to be left with the 2 2s. You see, what I did there was just to make sure that it's easier for me to do that. So even your second equation your first equation can also be multiplied so that you can align. Once you've got that alignment, then you are making things easier because these two just cancel out. Take away 4 from 42, you're going to be left with 38. Take away 10 from 100, you're going to be left with 90f. Now you see we can convert this now into a fraction. So that will be the fraction of 38 over 90, which if you simplify is literally just going to be 19 over 45 because 2 goes in here 19 times and 2 goes into 45 times. And just like that. So just remember, you have different multipliers. The key idea is to have an alignment to the side. All right. With that said, let's move on to the other question as well. Again, this question focuses on exponential growth. And like I said, you will know that it's exponential growth because usually at times it does not have any numerical numbers. And they will even tell you sometimes of the word exponentially. And whenever you're dealing with exponential growth, you need to use the formula for compound interest. Just bear in mind when they say decrease, you must use the negative. When they say increase, you must use a positive. So in this case, it's decrease. That will be 1 minus r over 100 to the power of n. Our principal amount, they told you at the end of 2021, there were 27,000, which means this was initially P. The number of rhinos is expected to decrease exponentially by 3%. That's our rate. Work out the number of rhinos expected to be living in the wild 4 years later at the end of 2025. And sometimes they won't tell you the number of years, like 4 years later, and then you now need to just subtract your years so that you can then find it. Like in this case, it's already direct because it told you 4 years later. That means principal amount is 27,000 and it's decreased. That's why I'm putting a minus. Minus 3 over 100 to the power of how many years? 4 years. Now, like I said, guys, in your exams, it will be very easy for you to solve this value. So they're not going to give you like values you cannot resolve. So like in this case, obviously, 3 divided by 100 is 0.03, 0.03. You take away from that, you raise that to the power of 4. If you're doing this now without a calculator, then you will end up with the following amount. You end up with the following amount of 23,903. So typical questions like this can be asked, but like I said before, they will be asked in such a way that it's easier for you to compute. Another thing that can also be asked really for numbers is sets. And for sets, it's just important to understand the universal set is always the sign, epsilon, which is always the one that harbors everything, because the universal set means everything. The intersection is what you find in the middle. Union is actually when you are combining like two sets or more sets together. And usually when you find something that's like this, AN, then the N in front here simply means number of elements. How many elements are in that set? And then something that's like this, complement means take away. And then you obviously have subset as well. There's no proper subsets anymore in the syllable. All right. So with that said, and then obviously intersection, I will show the signs just so that you can also recall. So like in this case, this here means intersection, but if I was to say A union B, which means I'm just uniting them. So, okay, good. How do I go about some of this stuff? That's the idea. We need to learn about this. So often at times when students see X is already like, kom ek los daarin. Maar dis is so. Jy is al klaar gesê, die is 'n universal set. Dit beteken alles hier is 'n universal set. And that, here what you said, the Venn diagram shows information about the number of elements A, B, and epsilon, which is a universal set. And it contains 52 numbers, which means all of this is supposed to add up to 52. Which means, really, I must just take the 15 plus the 5x plus the x plus 5 plus the 12 minus x must give me what? 52. This is how best I must solve this. Every time you look at anything that has got x, you know you're just supposed to solve it algebraically. So like in this case, now you collect your like terms. That will be 5x plus 6 plus x. That will be 6 minus the other x here. That will give us 5x, because 5 plus 1 is 6 minus x is 5x. 15 plus the 5 is 20. Plus the 12 is 32. So that will give us 32 equals to 52. Then obviously you minus 32 from both sides. You will end up with 10. Is it 10 or 20? 10, 20, 10. Is it 10 or 20, guys? Hope I just calculated that right. So give us 20, 5x. And to get your x, you need to divide both sides by 5, which means literally x in this particular equation is 5, which means if I put 4 here, I get 9. So at the intersection, I put 9. If I put 12 minus 4 here, I'm going to get 8. And here that would be 5 times 4, which will give me 20. And when I add all of these ones together, I must get 52 because this means the whole universal set must add up to 52. Then they said here, how many elements are in A intersect B? Now we found out A intersect B is almost x plus 5. And now that we know what our x is, that will be 4 plus 5, which gives us 9. So generally, questions like that can appear, and it's important that you do know how to solve it. Okay, up next, again, another question on sets. I just felt it's important for you to know some of these questions so that you know really how to approach it. It doesn't matter what they give you, as long as you just know. Like I told you now in the previous slide, this n just tells you, is asking you how many of them are in there. Here you are told we've got the following. On the Venn diagram, shade the region P union, not Q, which means Q is what we want to take out. Now remember, every time when we are shading, you don't shade what you are taking out, you shade what stays. So in this case, sometimes you can just even play around with things, hey, and you can just ask yourself, okay, this is the universal set. Let me say the universal set is going to be like 1, 2, 3, and 4. Okay? And then I go, okay, in the universal set, you contain all the numbers 1, 2, 3, and 4. In P, I have 2, 3. In Q, I have 3 and 4. Guys, Q is this whole circle, P is that whole circle. Now they said we don't want Q because this means take away Q. To take away Q, it means you're going to erase the 3 and the 4. Now, that means also in the whole set, wherever there is a 3 and the 4, it must go because it won't be part of it. So what's going to remain? It will be the 1 and the 2 and the 2 here, which means what needs to remain in this case will be the whole of Q, because the whole of Q is most the one we are taking away. So what are we going to shade? Like I said now, guys, we are shading what will remain. So which means in this case, the 3, whatever here, I just put the numbers here to demonstrate. So like in this case now, that's gone. That's gone. So that's what we mean by this. So the Q is gone, P remains. And what's going to remain of the P will just generally be like that part. Okay. Then here you are told the universal set contains 20, which means the whole thing 20. But then be careful here. They told you n, which means number of union. What does this sign mean again? It means take away. When you're taking away the union, do you know what union is? Union is when you are uniting like all of this. So if you take away the union, they're saying, if you take away the union, only one number remains. Now, if you take away the union, it means you're taking away everything else. So where will this number 1 be? It will just be on the outside. It will be on the outside because it says now you're taking away the union. So the number here is going to be 1 because it's the only one that's not going to be part of the union. Then you are told, okay, A contains 12. Now, when you're solving some of these things and you don't know what they are, just come up with variables. Like, let this be X, let this be Y, let this be Z. You are told from the beginning, the whole thing adds up to 20. Which literally means I can just say, okay, so this one outside here plus X plus Y plus Z must give me 20. I just need to figure out what is my X plus Y. Nee? Now, based on this, we are told that A is 12. And you can see here, in this case, my A is X and Y, which means this X and Y here will add up to 12. That means 12. 12 plus 1 plus Z. Now you see, the reason I did this is to allow me to know how to solve this. Then I can see, okay, let me find out what Z is. If I say 1 plus 12, I'll get 13 plus Z equals to 20. If I subtract 13 from 20, I'll get I will get 7, which means inside here, there is 7 numbers. Now that I know what Z is, and I'm also told in B, how many numbers are in B? 10, which means these two are supposed to add up to 10. So if I take away 7 from 10, I'm going to be left with what? 3. So that is 3 plus 7 will give me 10. What's my A going to be? My A, I'm told, is already 12 numbers. So let me take away 3 from 12. I'm going to end up with what? Is it 9, guys? 9. And just like that, you've solved it. So generally, sometimes, especially if you're dealing with this, just try and do that. It will really help you solve your problems. I hope that helps. All right. I think generally, again, it's fractions on this one. And similarly, this one was just also the same as the other one. I believe fractions. I don't need to do as much, but I can just do this one again. So again, we do 3 times 8 plus 1. That will be 3 times 8 will be 16 plus 8. That is 24. 24 plus 1, 25 over 8. Minus here, 1 times 4 is basically 4, plus 3 is 7, 7 over 4. But we are not done, so we need to make the denominators the same here. Now we need to just multiply this by 4, multiply that by 8, by 8, by 8. Is it by 8 or by 2? Actually, this by 2, man. Sorry, guys. It's too fast there. My apologies, my apologies, 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 apologies. Because we just need to make this the same. So we don't need to multiply by 8, but rather we need to multiply this by 1. Then we can multiply this by 2. Then we can multiply this by 2. Then we can multiply this by 1. Then you see here at the bottom, we're going to have 8. 25 times 1 will be 25 times 1 will be 25. 7 times 2 is 14. Take away 14 from 25. You're going to be left with, how much is that, guys? My mental math is disappearing. Hope yours is not. 11 over 8. And then 11 into 8 goes in there basically once. Remainder will be 3. 3 over 8. We can't simplify that further. You're done. Right, if I've made a mistake, just correct it, guys. But fractions is something that I believe you should be able to do. Then generally as well, they can ask you to find the highest common factor, lowest common multiple. And I always tell the students, whenever you're dealing with these things, use your prime factorization. Very simple. So in this case, I'm given this and that. So I'm given 12. I can just prime factorize that. 2 into 12 is basically 6. And then 2 also goes into 6 3 times. 3, 1. I do the same for the 8. 2 into 8 is 4. 2 into 4 is 2. 2 into 2 is 1. Now, when you're dealing with, if this was highest common factor, we would just take the common numbers. Like in this case, it will just be 2 and 2. And the highest common factor of this will be like 4. Because 2 times 2 is 4. But if you're dealing with lowest common multiple, you take the common, which will be in this case 2 times 2 times 2. And then you also multiply the uncommon, which will be 3 times 2. Literally 4 times 6, which is 24. And then for the powers, you just take the highest power. Then it becomes literally 24x to the power of 12. All right. Very simple indeed. And also do note, guys, sometimes this is just a common percentage, but they can also ask you guys reverse percentages. I hope you guys remember it's x times the multiplier equals to the original amount. And then you must just know this was reduced by that. If it's reduced, you must minus that percentage from 100 to get the multiplier. If it's increased, then you must just add that percentage to 100 to get the multiplier. And say for instance, if I said this was reduced by 20, I will then minus 20 from 100 to get 80. And I must divide this 80 by 100, which will give me 0.8. That means my multiplier will become 0.8 with whatever actual amount that I had here. Then I'll get the original amount. If it was addition, then I'll just obviously, they said increase, then I'll add, and I'll get 120. 120 divided by 100 is 1.2. 1.2 times that amount will give me the original amount. This is now for reverse percentages. So reverse percentage can also be asked in paper 2. And there are quite a number of examples that you can go through there as well, which I'm confident that you guys can and will be able to do. And in general, questions as well can be asked. In this case, this is just a direct one. I just had to explain this just again to remind you that yes, they can ask you something like that. Here you're told Oliver sends 22% sent 22% more messages in June than in May. He sent 300 messages in June. So find out how many more messages he sent in June than in May. So typically, many people here would have done that, which is just literally taking this and then you figure out what is 22% of this. 22% of this is 67.1. Then you take that 67.1 and then you literally add it to that. Then you'll get your answer, which is literally just 372.1. But like I said before, this was taken from my non-calculator paper. Non-calculator, you will not get values that are like that. You get values that are easier for you to work with. All right. Then they also like these questions on density or finding whatever, sometimes even pressure, but they will give you the formula. You must just see what you are given. If you are dealing with paper 2 now, if you are dealing with a question that has got pi, they will just tell you to write your answer in terms of pi, which means pi you will not operate, you just write your answer in terms of pi. In this case, we are told a bronze sphere has a radius of 3.6, a density of 8.05 grams per cubic centimeter. Just make sure that your units somehow are the same. If this was in meters, it could have been a different case because then you need to probably convert the meters to centimeters. Otherwise, it won't cancel. Find the mass of the sphere, and then you are given the densities formula. And they said find the mass, which means you need to make mass the subject of the formula in order for you to actually find that mass. But literally in this case, we know what the density is, but we don't know what the volume is. But we are given the formula for the volume. So we can just take that multiplied by this. Now in this case, guys, you will just have to compute it. So this will give us then 195.4322. Please do not be worried. In your paper, you'll be given values to work with. This is going to be in cubic centimeters because it's volume. And then if you make mass a subject of the formula, you will see that mass will then be equals to density multiplied by the volume. And the density is 8.05 grams per cubic centimeter multiplied by this whole thing here. You can see now this will cancel. Then we'll get our answer in grams, which is like 703 point something. But we are told to leave our answer. Okay, they told us give your answer in kilograms, which means we need to divide this by 1,000 at the end, which will then give us 0.7 kilograms. So generally as well, questions like that can appear. They will give you the formula, don't worry, and then you must just compute. So generally those are questions you can get on these. And what's new for the 2025 papers is surds. Surds, like I told you guys, is just radicals. You can be asked to make these radicals same. You can be asked to expand them. Just be careful when you are adding, the radical must be the same. When you're adding or subtracting, the radical must be the same. So like in this case, it's just expanding the radicals, so you need to multiply them. Eh? 2 times 1 will give us 2. 2 times, remember now that 2 is not going to multiply with a 5 inside. It will be multiplied with a number outside. Just be careful with the sign. It's 2 times negative 3 square root of 5. So that will give me negative 6 square root of 5. And here you can see it's negative square root of 5. So it's negative 1 here in front. Negative 1 times 1 will give me negative, and it's just going to be negative square root of 5. Here I'm multiplying negative square root of 5 with negative square root of 3, 5. Now here, if you are multiplying, the numbers just multiply inside, like the 5. If you are multiplying roots that are the same, or any roots, it will be 5 times 5. But you need 5 times 5 is just 25. If the root is the same, the root will just cancel and the number will stay. So you don't necessarily have to say 5 times 5, then you put it in a root again. No, just know that the root will cancel because the number is the same. So this will be a negative multiplied by a negative will give me a positive. So that will be positive 3 outside, but 5 times 5, like I said before, now square root of 5 will just be 5 alone. So that will be 3 times the 5, which will give me 15. These roots are the same because they're all 5. In front here is a 1. So now we can simplify. These are numbers. So that's 2 and 5. 2 and 5 will give me 17. Then here I've got negative 6 minus negative 1 will give me negative 7 square root of 5. This will be the simplified version. So things like that you can also get in paper 2. So bear in mind. Then you will get the question where you might be asked to rationalize the denominator or numerator. In this case, if you only have a single root, you don't need to make it positive or negative. You just multiply with the same root. So in this case, I need to rationalize, and I'm just doing whatever I'm doing with the denominator, I also do with the numerator. So I need to get rid of the root. And you know when the roots are the same like this, they'll cancel out. So 10, square root of 10 times square root of 10 at the bottom, we'll just leave it with 10. And this will just be 6 times the square root of 10. Now, if the numbers can simplify, you can simplify them. The square root of 10 is not defined. But if I have got like 6 over 10, this can be simplified. Because 2 goes into 6 3 times and 2 goes into 10 5 times. So the number can then be written as square root 3 square root of 10 over 5. That's in its simplest form. So you can be asked to rationalize some of this stuff. Similarly, this one as well, it's just the same as the other one. 9 square root of 3, rationalize this again. Sometimes they might tell you to rationalize the numerator. Then if this was the other way around, like square root of 3 over 9, then they would have told you to rationalize that. So then that will take us now, we must do the same here for this. This will be, this root's just going to cancel. Then we're going to be left with 3, 9, square root of 3. And this can still be simplified because 3 goes into 9 3 times. Simple. So this is surds, and it's actually easy marks if you just know what to do. Now, at times, I like to confuse students, and then they tell you, nah, yes, find your answer, find the value of C, find the value of K. That simply means when you are done with this, what are you going to, you must end up with a value of C and a value of K. What are those values? Similarly, what we did with the other one last time, we took now this whole thing the way it is. We first need to solve it so that we can know what our values on this side are going to be. 5 times 1 is 5. 5 times square root 3 square root 2. That will be 5 times 3 here, which will give us 15 square root 2. Negative, be careful. It's negative 1 times 1. That will be negative square root of 2. Negative square root of 2 multiplied by positive 3 square root of 2. In this case, it's a negative multiplied by a positive, or it will just be negative. Remember now there was a 3 there already, so I'm going to put the 3. Because these roots are the same, they will just cancel, and there will only be 2. So hence 3 times 2 will give me 6, so that will be negative 6. And here negative 2 plus 15 square root of 2 plus 5. These are the numbers, so I can subtract the 6 from the 5. I will be left with negative 1. You can see now these roots are the same, but there are numbers in front. So this is a 15, and there's a 1 here. So 15 minus 1 is literally 14. So that's negative 1, 14 square root of 2. Now you see it's in the form where we actually wanted it to be. So that's my negative 1 is my C. My value of K, which they are saying here, is 14. Finish. Quite straightforward when you're dealing with surds. The other one that they can ask you, and I actually gave you guys a very nice technique, is to simplify. Now you see here, I can't add these things because the surds are not the same. So what do? I need to make the surd the same. And what I start off with here in most cases is to simply do what we call prime factorization. So I've got 27. So I use my prime factors. 3 goes into 27 9 times, and 3 goes into 9 3 times, and 3 goes into 3 1 time. You see why I do this. It's actually a very simpler way. You can't, whenever you are adding sets or subtracting them, you need to find use your prime factorization so that you can find common roots. 2 into 12 is 6. 2 into 6 is 2. Actually 3. And 3 into 3 is 1. Now you see here, 2 times 2 is 4, and 4 is a square number. And here, 3 times 3 is 9. 9 is a square number. Now, instead of I can rewrite these things now. And I will say 9 times 3 will give me 27. So I can rewrite it and just say, okay, no. 9 times 3 is 27. Plus 12 will now be 4 times 3. Now you see here, the 9 and the 4 are square numbers. Square root of 9 is 3. So the 3 goes out. And the other 3, which is here, stays in here. And then here, square root of 4 is literally just 2. So the 2 goes out, square root of 3. Now you see my roots are the same. Now I can add them. That's why they said simplify. So I'll add the numbers that are in front, but nothing is going to happen to the root. So 3 plus 2 will give me 5. 5 square root of 3. That's my final answer. So that's generally, guys, how you go about it. And it's good. Do a few couple of practices on your own. And then here, it's division of surds, and they also said that we must find the integer k. When you are dividing and multiplication is just joining. So here in this case, I can just rewrite this as 40 over 5. Instead of writing this thing separate, I'll just write one long root, which I put the 8 over 2, because I'm joining them together. 2 into 8 is just what? 4. So I'm going to end up with the square root of 4 here. 5 into 40 will literally just be 8. So I have 8 here. You see, what I did here, guys, this is division. So I just put this whole thing into that. And 5 into 40 is 8. But we know what the square root of 4 is, isn't it? Square root of 4 is 2. So that would mean 8 times 2, which is 16. So this value of k that they are saying we must find is 16. Don't go and cross multiply, guys. No. It's a surd. So they're just saying, no. Solve this and find out what the answer is going to be. Okay, and then the last one for numbers is surds again. But this time around, we are rationalizing. And we are rationalizing the denominator. But you see now here, I've got more than 2 terms. To rationalize, it simply means I must get rid of this root. And if I've got things that are like this, I must use the opposite. So I must actually use the opposite of that, where I'm adding. Put that into brackets like that. And then I go 1 times that. It's going to give me 3 plus the square root of 5. And then here I'm going to have 3 minus 5 square root of, because I'm multiplying this 2. It's multiplication. Literally now, the top part is going to remain like that. So it's going to be 5 square root of this. We need to solve the bottom part. 3 times this is going to give me 9. 3 times the square root of 5 is going to give me positive 3 square root of 5. Negative square root of 5 multiplied by that will give me 3 negative square root of 5. And then here, now remember, we are multiplying similar roots. So it's negative square root of 5 multiplied by positive square root of 5. The roots just cancel, and you're just going to end up with 5. But it's minus 5 because we are multiplying a negative for the positive. These two are the same, and you can see they are opposite, so they will just cancel. That's why we are saying rationalize, because the root must go. So I'm just going to end up with 3 plus square root of 5. Take away 5 from 9, I'm going to end up with 4. And just like that, you have rationalized. Ladies and gents, to do numbers in paper 2 is actually easy. Now, my task to you is the following. Take your question papers from 2021, go all the way up until 2025. Dan practice jy net. Jy's reg. Practice jy net. Daai hele paper 2's daar. And then you see how this one's look like in terms of the structure. And then your mental maths in terms of arithmetic must be good. With that said, guys, I believe you guys are going to ace it. That was it from me for numbers. I hope you enjoyed the video and wait for sprint number 2, where we talk about algebra.